on the topic of scaling continuous integration, and then we'll leave about 10 or 15 minutes at the end for questions that you guys may have. Along the way, you can keep posting your questions just to make sure you are, if there's any particular question that is such that needs to be covered in the flow, then I'll make sure I inject that into Chris so he can cover it. With that, let me introduce, and we will make the document available in a day or so to people who have registered or attending the webinar. So Chris, let me introduce Chris. Chris is an expert in software development methodologies and process improvement. He helps companies to discover and implement their ideal processes and get them to the next level. His experience dates back to his days as a build and / release specialist and software engineer for IBM Rational. So he's a really qualified person with us to cover today. He has also filled the roles of developer, release engineer, and SCM consultant for a number of organizations. In addition, he's a certified Scrum Master and a frequent speaker at Accurate seminar series, and I'm delighted to welcome Chris to the Synergis webinar today on continuous integration. So over to you, Chris.
Thank you very much, Man. How are you? How's everyone doing today? Welcome to our webinar. I'd like to start out by, really talking about what software projects are like today, versus how they used to be, maybe even just a few years ago, maybe even just 5 years ago. Right now we live in a world of rapidly changing requirements, and if we're slow to respond to the market or customer demand, especially with the way that some of the Agile methodologies are coming up and taking over software organizations, if we don't respond to customer demand really in a quick way, we really risk catching up. So, I remember developing software back in the day where we'd write down all the requirements and then work on a 6-month cycle or a 1-year cycle to kind of release that software. But now we live in a world where those things are rapidly changing. Speaking of life cycles, because of these rapidly changing requirements, we have a faster time to market. So release cycles now are down to months or weeks versus that 6 months or years that I just talked about. And that means all the things that you had to do over that year are now kind of sped up, especially when it comes to building the software, releasing the software. Any branching and merging that you had to do, maybe once over the course of 6 months, you now have to do every 2 weeks, or building that software and packaging it up. You now have to do this every 2 weeks. So a lot of this automation and continuous integration plays into that quite a bit. Really needs to increase, or really needs to be adopted a little bit more if you're going to be releasing in a shorter life cycle. Now, because of this, we found that software projects are also difficult to accurately predict. Since we're reacting to the customer demands, we're taking feedback, projects are often changing. Even if we do have iteration or time boxes that are a set time, having a finished product or knowing when to release something may not be always fully understood until we know what it is that we're delivering. And of course, we have a quality challenge. We might be low on the type of defects that we have, but how do we know if we're even meeting customer expectations? And of course, we live in a world that is highly distributed. I don't know any software organization now that doesn't have people working, or some people working remotely. So this is a little bit different than the way that I used to work in a software development team where I had over the cue ball communication, but now we live in a distributed team or a distributed world where we use email and all those types of things to communicate with each other. So these are some of the differences in software projects yesterday versus today. And today we're going to be talking about continuous integration, but I want to kind of set the stage on why process is important and really where CI fits in this. If we think about process, process connects all of these three things to create a framework. We have program and project management, which is our business objectives. We have technical practices like continuous integration and Scrum, and then we have supporting tools like our CI server or our SCM tool. And really mature processes are predictable and repeatable, all right? And they all feed into each other, right? If we have the right tools and we have the right technical practices, we can certainly achieve all of our business goals. Now, practices are more complex than ever, especially with Agile, Scrum, continuous integration, all those things. So being able to practice them and repeat them is very important. Now, CI really helps in this space because CI is going to help us with that process and feedback. And CI really is a combination of technical practice and supporting tools underneath it. So with that, I'm going to give you guys a little agenda today. We're going to give you a quick intro into continuous integration, an overview of parallel development and why people create parallel projects in the software world, and scaling CI and using parallel development at the same time to kind of achieve maybe a multi-stage continuous integration setup. And then we'll have some time for Q&A at the end. So if I had to go over what the current state of continuous integration is, I think everyone knows that they should be doing continuous integration. A lot of software shops that I talk to do have some form of continuous integration running. That means that the check in some code and the build is running. But a lot of times I find that a lot of people are doing it, but they don't understand why they're doing it. So we'll get into that a little bit more later. But if I had to look at the industry overall, I do believe CI is a best practice, and people are pretty much adopting it wholesale. And they're trying to figure out how to best do that. Now, something that's come on in the last couple of years is attaching other automated processes to the build, such as an automated test or an automated deploy, or maybe some other dependencies like automating a database update. All right, so teams are starting to do that. Teams are starting to look at how to automate that process. But often teams are struggling to do that well. There hasn't been some industry standards set out just yet. And I think as a community, we're still trying to figure out the best way to bring these two things together. So what's important when scaling continuous integration, which is some of the things we're going to talk about today? We want to talk about feedback and quality. We want to talk about developer downtime, and we want to talk about automation. These are the three important things when we scale CI, especially if we're scaling CI in a team that's maybe over 10 or 20 people. So speaking of traditional development versus modern development, this is a little animation we made up here that is over the course of a few months from January to September. You can see that we designed, specified, and planned a software project. We had people, figuring out what we're going to work on, and then we spent 3 or 4 months coding. All right, and I'm sure we all remember this. We would code for 4 months, and then we would do this big bang integration merge. That's this little star here. There's a little explosion. That was when we found out. That's when the developers got the feedback if that their code changes actually work with the other teams that they're dependent on. So we had to wait 3 or 4 months for that feedback to even get to them. And that is the traditional way that we used to develop software. And this is really how CI kind of fits into that Agile process that we talked about. If we time box things and we get some feedback, we'll know if we need to improve or to change. From there, we'd probably send that over to documentation, and then we'd have some QA testers test it. And this is really that big bang traditional development scenario, and it's really not how people work now. Now, one of the things about traditional development is that developers had a great way to work in isolation. They craved it. They love working in isolation. Developers want to be able to sit down for a few months or sit down for a certain period of time, finish their work, not be disturbed by anybody else's changes, and then maybe a few months later go ahead and check in their code. But this isn't really realistic. Traditionally developers working in isolation is good for the developer, but overall it can be bad for the organization. If you have too much isolation, you'll end up in a scenario called merge hell. This is the industry term for when you spend a month trying to merge 2 code bases together, a week, or maybe you can't merge them together and you have to go back and recode something. All right, so isolation can lead to merge hell. So you have to be able to kind of figure out a way to balance that and figure out a way to provide just enough isolation and just enough integration at the same time to avoid that merge problem and to get feedback to those teams. And CI is a great way to kind of drive that process. So when we talk about CI, And we talk about minimizing that integration pain, that merge hell that I was just talking about. The solution typically to avoiding merge hell is to commit early and often. And by committing early and often, I mean checking your code every day or as soon as you think it's finished, or every hour. Some companies even put developers on a schedule where they go ahead and check in every hour. I wouldn't recommend that. But committing early and often is the best practice for avoiding merge hell or avoiding that big bang merge. But there's kind of like a implied condition here. The implied condition is that each integration will not decrease the code quality, but we don't know if that's actually true. The dark side to committing early and often is that we break the build more often. And we also might pollute our code base with something that might not be finished or something that might not be ready to share with another team. All right, so the rest, the point here is that committing in early and often is a best practice, but we also still have to balance that and manage that process and implement it in such a way that the code quality doesn't decrease and we don't end up with some sort of pollution of our code base of unfinished code or broken code. So in order to figure out how we determine if the code is okay, we have to test it. So to determine code quality, we can perform a test, and maybe we can even run a build against it. All right, and this is how we get the CI servers to build and test that software and provide feedback. And many of you are probably saying, well, this is just a build. Why is this so important? It's very important because it is a rudimentary test. It's not just a compile. It's actually a test that tells us that what we did is actually still good. So it's so simple but so very important. A build and maybe even a unit test attached to it is a rudimentary check on your code base. It gives developers important feedback that they're still alive. I'm going to use a cheesy example, but it's the example is that the CI server is really the heartbeat of the development organization. It's similar to the heart rate monitors you might find in a hospital. If it's constantly beeping, we know that we're still alive. If it makes that long, drawn-out beeping noise, we know that something's really wrong. We need to go fix it. All right. So the CI is almost like a way to alert you that something is actually wrong, and that's really what CI is. CI is an important way to tell the development organization that they are alive and that they're getting the feedback they need to keep going and fix whatever problems they have. Now, I've talked to many people that are doing CI like I mentioned before, and I asked them, what is continuous integration? And I've gotten some very funny answers. Some people have said, oh, it's just running the builds all the time, or it's binaries on demand, or it's a server that sits in the corner and runs the build. It's something that the release engineer cares about. It's automation of the builds so the developers don't have to do it on their local machine. Well, the thing is about CI is that it's not really about these things. These are all benefits, or these are all some things that are done with CI or are a feature of CI. But what CI is really about quality and feedback. It's really about getting that feedback to the development teams so they know that they can fix something. Now, at the bottom of this page here, you may notice that I have this is an Agile feedback loop. I got this from the Wikipedia page of Scrum, I believe. We have a product backlog, sprint backlog, and then we do a sprint, we get a working increment of software. Now, CI is very similar to this. During the sprint, we get this feedback loop in 24 hours or 30 days or however long it is. We get a feedback loop telling us with our working increment of software that it was good or bad or that we need to change it. We've shown it to someone and said, hey, is this a good idea? And think of CI like that. CI is that working increment of software. It's telling the developers, hey, this is still good, or hey, this is no good. It's a feedback loop, and feedback loops improve quality. All right? And that's why people always associate CI really with part of the Agile movement, because it's reducing waste, and it's also providing a feedback loop to improve that quality. So what do we do when we want to scale continuous integration? If we have too many committers on the same code line, if you're doing mainline development, if you're committing code to trunk, the likelihood that something is broken is actually very high, especially if we have a lot of different teams and a lot of different people committing to that code base. I've worked with several clients here some accurate prospects that would have build failures that lasted 8 hours, and people just stopped caring about the build failure. All right, and that wasn't really any meaningful feedback for people. If they went several days, if they went a week with a broken build, they just kept coding. And at this point, you're just piling onto a broken code base. So if the feedback is meaningless, and productivity will continue to suffer, and CI just becomes constantly broken. And really, I like to call this problem continuous noise, where I'm being barraged with these messages that say, oh, the build's broken again, and everybody rolls their eyes and they continue to work. This is not good feedback for anybody. Just automating it and then having it break all the time is not continuous integration. That's just continuous noise. So before I get to solving the continuous noise problem, I'm going to give you an overview of what parallel development is with an SCM system, and I kind of want to relate that problem of continuous noise to the process you might be using with your parallel development objectives. Some of the reasons that people work in parallel if they're working in their SCM system is various based on maybe not optimization of their process, but really about business needs. All right, some people may create a branch for patches, or one for a customer, or something for development spikes to experiment or integrate some sort of feature that they're working on. Maybe you have to create different code configurations based on environments such as QA, or user acceptance testing, or maybe you have a branch for special content. But the idea here is that when we talk about continuous integration, the integration actually happens on the SCM system. And if we're doing mainline development, which is typically what most people do, and we create different branches that do these things, we're not really focusing on the CI problem. We're not really automating or scaling the CI problem. We're really just doing branching based on what happens to us in a business type capacity. So we just go ahead and create these branches based on whatever comes along. So we need to think about the process in a bit of a different way. How do we manage that process, from a Agile perspective, to go ahead and create maybe a multi-stage continuous integration setup to manage that process? So if we're going to set up something, if we're going to set up parallel development to support multi-stage continuous integration, we also have to support many different things. We have to support the ability for the team to deliver faster and receive rapid feedback, meaning that I have to support, of course, Agile initiatives, and I have to also coordinate a lot of workflow in there. And that means that I can go ahead and create workflows that support all kinds of different things, such as different releases, staggered feature schedules and patches, and kind of push code through a workflow and give teams rapid feedback. And that's the whole idea behind this. If we're going to scale continuous integration, and we're going to scale it with workflow, and we're going to scale it with our SCM system, we need to be able to have a way to do that. So we're going to talk about, excuse me, I'm going to go back to the old slide, the previous slide there. We're going to talk about now the scaling CI and the parallel development challenge. So how do we kind of mix these two things together? How do we use parallel development initiatives? How do we use SCM initiatives to scale continuous integration? So before I kept mentioning isolation. Developers love isolation. They don't want their work to be disrupted by somebody else's crappy code. And we also have to provide a way for them to check in early and often, right? So we have to combine these two things. There needs to be a balance between just enough isolation and just enough integration. And this balancing act, if we think about it, we really want to have a way for our developers to continue working on their local changes, but maybe pull in new changes from other teams automatically, or pull in finished changes from other developers when those developers say it's done, or maybe when those developers have run a continuous integration build against it. So the idea here is, how do we provide isolation and integration at the same time? Can it be done? If I had to go on and explain integration a little bit further, integration is when I talk about integration, I'm really talking about bringing code together, merging code together. Integration is really easy with just a few people. Now, I like to tell this story a lot. One day our VP of marketing here had told me that writing software is very much like writing a book, and I thought that was kind of a funny thing to say. I didn't really think about it that much, but later on that day, it occurred to me that he was a little bit right. He had, writing software very much is like writing a book. We have to take a story and bring it together, but we're writing a book with many different people. So if you notice here in this diagram, I have several different developers writing different chapters, right? These are different writers, and if they have to write these different chapters, and some of them overlap, you'll notice chapter 1 overlaps with a lot of different developers here. They can bring that story together fairly easily. They can talk to each other, they can figure it out, and they can write the book. But in real life, when we have to scale this, if we have a larger development team, and they're all writing this book and they're trying to make it good for the reader, it becomes a little bit harder. All right? And in reality, we also have many different teams working on this. We might have teams all around the globe. And we also might have several different books that we're working on that are all related to each other. So I guess software development is kind of like writing a giant book, I guess. But when we start managing this process, when we start thinking about this process, sometimes it's hard to figure out what's going on. It's hard to figure out how we integrate all of these code changes together and then get feedback to these different teams so they know if they broke something or they know that the story doesn't make any sense. And the cost of this integration can be fairly high. So we did a simple, a little bit of math here, a very simple example, but we think about if we do mainline development like I just described, where we have all of these developers checking in to one place, or checking in or writing all of that story for one book. If I had to take per week the number of check-ins per developer, the number of developers, the percentage of check-ins that break code, the numbers of problems encountered per developer, and the length of time that the problem occurred, if I had to add this all up, the numbers actually end up being pretty staggering. If I have 200 developers in one team, or maybe not one team, but I have 200 developers in multiple teams. Maybe they work on dependent projects. Let's say that every day, I'm going to use some very low numbers here. If a developer has 2 commits each day and 1% are bad, that is 4 build breaks a day. That means that that code base is now broken. QA testers can't test. Other people can't check into broken code. They can't build on their local machine, and they can't share code with each other. Now, if each breakage cuts productivity by 50% for 15 minutes, we'll lose 100 dev hours per day. Now, by conservative estimates, $50 an hour for a developer would equal $5,000 per day. That's quite a high expense for something that might be able to be avoided if we can figure out a way to have, some better integration. We might be able to get around this. All right, so $5,000 a day is approximately $100,000 a month, and maybe $1.2 million per year. And this is a pretty shocking example, and I'm using very low numbers here. I mean, 1% commits that are bad is actually a very low number. We know that developers are committing code that's bad all the time, and that's just the nature of development. We want them to do that. We want them to experiment. We want them to check in code that might break the build. All right. So I'm going to introduce to you the concept of multi-stage continuous integration. Multi-stage continuous integration is the idea that we will provide integration or continuous integration at the team level or at the workspace level, and then have integration points so those teams can get feedback from each other. So please excuse the rapid animation here, but you can see here I have on the left developers checking in code to their local workspaces. Now, this is where they're just going to check in their code to their private sandbox, and they're going to send that code up to their team area, their team branch maybe. So team A, think of team A as a branch. We're running continuous integration at the team A level. All right, and you'll notice at the bottom we also have a team checking in code to the team B stream. Now, the idea here is that I run builds every few minutes on the developers' machines. They're checking if it's good or bad. I run continuous integration at the team level every hour maybe, depending on what kind of interval I want to set up for that continuous integration. And then maybe daily, I run a much larger build at the integration level. So I kind of want to isolate these code bases out, isolate the builds, and then integrate later. And the idea here is that I'm really only passing finished code to that integration level to provide that bigger build when I know it's past continuous integration at the team level. So we've kind of separated that out. Now, once the integration build passes in the integration level, we then send the code back down to the Team A and Team B branches. So the idea here is that we use a promotional style branching model to kind of facilitate this process of creating different code stages to produce builds. And this will reduce the problem of continuous noise. All right. Now, in the situation where I might have all these developers checking into one place and breaking the build all the time, that feedback is no longer good to them. All right. They don't care if Team A or Team, so Team A doesn't care if Team B broke the build. All right. That's not productive for anybody. But Team A, if they break the build, all the other members of that team need to know that and need to react to that. All right. So we want to be able to separate this out kind of a way that they can work in parallel and they can have continuous integration in parallel. And this is called multi-stage continuous integration. Now, beyond multi-stage continuous integration, I'm going to talk about some different things that happen at different code stages during the life cycle. And this will all pull into the continuous integration model in a little bit, but I'm going to use an example from, I'm actually using Acura in this example here to give you guys a real-life example. What I've done here is I've chained together 4 different streams or branches, for those of you that are used to another type of source control system, but these are similar to branches. And the changes go from right to left. I have a dev branch, a QA branch, a user accepting branch, and a production branch. And I'm going to push code between these branches from right to left and produce some builds. Now, what's interesting about these different stages of the development cycle is that different things happen at different times of the cycle. And they also require different amounts of human interaction, different amounts of time for the build, different amount of resources, and really it's really about automating that process of providing different things at different stages. So further extending the multi-stage continuous integration aspect of this, we really have to also separate by stage. All right. So at the development level, where maybe one of those teams are checking in, during one iteration I might do, or 1 week, or maybe 1 day, it depends on the team, I might do 60 builds a day. All right. During the QA builds, or that week or that day, I only do 30 builds. For user acceptance, maybe I only do 3. And production, I only do it once. We also have to manage all our resources at those different stages also in terms of machines. So at the dev stage, I might do 1 build, or I need 1 machine. At the QA stage, I might need 4 machines. At the UX stage, I might need 10. When I get to production, maybe I have hundreds of machines that I have to use to get this build out the door. Now, you'll notice at the top I have different things listed for each stage. At the dev level, I have continuous integration. At the QA level, I do continuous integration, automated tests, unit tests, binary deploy, database deploy, web deploy. It's slightly different for user acceptance testing. I have a customer sign-off. For production, I have to get operations involved. I have IT sign-off. I have to do another binary deploy, and also have a rollback plan if I need to. So you'll notice is, you know, when we move through this process, we even have to require different amounts of people for each stage. We also have to plan for different amounts of time for each one of these stages in the development process. So using this branching structure is really powerful when we have to scale continuous integration. And really the point here is that we need to have different code configurations that scale out depending on what the needs are for each stage of the development process. All right. So we're really talking about this multi-stage continuous integration process.
Hey, Chris, can you clarify one question here, which is probably for the slide, on this slide, is the people that you're showing here, who are these people? These are people who are helping, these are build engineers, or what's the, and then similarly, what's the timeline here? This is the amount of time it takes for each continuous integration build. Can you just clarify?
Great. Yeah, great question. Really the point here is that there's a lot of different resources at each stage of the process. And these people could be release engineers, they could be operations people. Typically, if I push something to production, it's all hands on deck. I need some developers, some QA engineers, some operations people, some IT people. And they could be any mix, really. But the point here is that, you know, if I'm doing simple continuous integration, I really only need, maybe I don't even need anybody. Maybe I just need a machine running or 1 person to help manage that process. But, you know, when I do a production deploy, a production build, I might need a lot of people to help manage that. As far as the timelines, I'm really talking about how long it takes to get all of those things done on that list at the top. it might take 5 hours to do a production deploy, and that might simply be because how many machines there are. But if we're doing development continuous integration, maybe it only takes 10 minutes to get that feedback to the developers. So we imagine this as a process flow that really has different resources and different times and different types of machines associated with it. And being able to categorize it like this, I think, is a very powerful thing because it helps us kind of automate those resources as we need to.
Okay, great. Thank you.
No problem. Now, further extending on this example, when we talk about continuous integration and we talk about multi-stage continuous integration, this is another real-life example that I'm using from Accuriv. I have some team-specific continuous integration running on these teams here. So I have some massively parallel teams here. I have a core team, DB, feature. You'll see these are just different teams working in parallel. And they're all running continuous integration at the team level. Now, when we talked about those stages before, when they finish and they move code up to the QA level, they also run all these different automated things that come with the continuous integration activities or continuous integration build. When we push to UAT, they also do some other things. We push to production. We also have that database deploy. But the main point of this slide is to show that, what we want to do is from the dev team area, so all of these dev teams working in parallel, when they push code up to QA, if QA, if the continuous build passes in the QA stage, or if the automated test pass or the unit test pass, we want to be able to share code with the rest of the team. And the idea is that they can stay isolated, they can get continuous integration on broken builds if they want to, but if they push up to QA and the code breaks, they don't receive any changes from anybody else. But if the build and test pass, we automatically can push code down to those other teams. And you can set this up in many different ways. There's some systems that do this better than others. But if you want to automatically push code down based on build results or push code down based on unit tests or based on maybe even a sign-off, you can do that. And the idea here is that we want to provide just enough isolation for these teams to continue working and fix their broken builds. And then also have enough integration to push down what we know is a good piece of code that can actually compile and share that with other teams. So they're never sharing any broken build, they're never sharing any broken code, and they don't suffer from that continuous noise that we talked about before. So now to change gears just a little bit, we talked about the different code stages and all of the things that have to happen when somebody moves code between different code stages or when they want to push code up to QA or they want to push code to production. But we also have to be able to manage those configurations. So you notice that we had so many different things that we did at QA that was different than what we did in UAT. Well, that means that we have to be able to manage we have to manage a build and deployment configuration. And the idea behind this is that we have set rules and set things that we do for each team, for each stage of the development process. We manage it so you can maximize reuse and potentially create them dynamically if you need them. All right, this means if somebody creates a new project, you already have the infrastructure set up to go ahead and handle that. As far as tests go, having core regression suites shared across code lines is a great thing to have. And another part of this is that you may not want to always run those tests for every build, meaning that in the development stage of the multi-stage continuous integration, maybe I run a simple build. But at the QA stage is when I run the regression tests and automated tests for those teams. And having that shared across those different code bases is also a very powerful thing to happen. This is another topic I touch on quite a bit, which is test environments. With all the tools we have at our disposal today, with all the tools that we have at our disposal today, with VMs and cloud-based solutions, there's no excuse to have enough test environments. And I can't tell you how many times I talk with software development teams where they can't reproduce a problem in QA that they can produce in production because they don't have an environment. All right, so having test environments and having a cheap way to spin up a test environment to deploy what's in production and take a look and see if you can figure out and solve those problems is really a huge thing to have. There's no excuses to have that in this day and age, and investing in that will really really increase your team's productivity. So, in closing, I think that, the compile is a first test, really a powerful first test. Like I said, that compile, that first CI build is really the heartbeat of the organization. It's how we know we're alive. And a lot of teams right now are mastering that. A lot of teams are certainly doing continuous integration, compiling it, and getting their results and getting feedback. Unit test, deploy, any other type of automation can always come after. And right now in the industry, people are still figuring out how to do that, but there's some really innovative things happening right now, especially if you look at continuous deployment or some of the automated testing that people are doing before they're pushing their solutions out to production. It's getting very interesting. Really, you want to get feedback as fast as possible. Getting feedback really is the name of the game in CI, and really CI is not about running the build all the time. It's about getting quality through feedback. That's how CI is going to help your development team. Another thing to keep note is that different teams need different types of builds, so providing the right type of feedback is also important. 20 messages that say that the build broke from different teams is not useful to anybody. You want to know if you want to be able to send targeted feedback to people so they can take action on it. All right, people often will fix things just to keep things tidy because that's how we do. That's what human nature is like. Having separate code configurations based on the process is a hugely powerful thing to have. It's really the key to setting up multi-stage continuous integration and having a way for teams to go ahead and build based on whatever their needs are. And of course, it's really about people. It's really about feedback. But having the right kind of tools obviously helps. Some do this better than others, but it really is about people, and it really is about getting feedback and improving quality. Now, before we get to Q&A, just to give you guys a quick overview of what AccuRev is and who AccuRev is. At AccuRev, we believe that SCM is more than just version control. We believe that SCM really has a profound effect on the day-to-day lives of developers, and we think it's the hub of the development team. It's really where innovation takes place, and it touches all aspects of the development process, all the way from build to test, project management, developers. It's really the centerpiece of the process. And speaking more about that, AccuRev really is just more than version control. AccuRev is version control plus visual process automation, automated change management, best practices for Agile like continuous integration, parallel development, compliance, SCM, and distributed teams. And that's really who we are in a nutshell. And with that, I think I'll give it back for some Q&A.
Excellent. Thank you, Chris. This is an excellent presentation. Let me do the mechanics of presentation change here so we can cover the rest of the Q&A topics. So all of you who are with us on this now should actually, let me get to the right page, give me a minute, and should have it. Okay, I think we're getting there. Cool. Okay. So all of you should be able to see the Synerzip page now. So that this is a time in the webinar now. You guys can reflect upon what Chris covered on continuous integration topic, and we already have some questions. But if you have more questions about how this applies in your world, please put those questions in the Q&A panel of GoToWebinar, and I'll keep track of those questions and come to that in just a minute. And while you are doing the questions, adding your questions in the panel, I'm going to just take a couple of minutes and introduce Synerzip, and then start taking questions. Okay. So Synerzip, in a nutshell, we are a software product development partner for small to mid-sized technology companies. Our typical clients are venture-backed companies in growth stage when they need to significantly expand their software development team, and all the work we do is intellectual property of our clients, and we help our clients in the entire software development life cycle from design, development, QA testing, deployment, configuration, and so on. And for each client, we put together a dedicated team of high-caliber software professionals, which seamlessly extends their in-house engineering team. And these teams are very high-caliber teams and very low turnover, very stable teams. But we are much more than just giving staff augmentation. We are actually a full development partner for our clients. And because of our experience in Agile software development practices and in general software development area, going back to more than 2 decades now as professionals, we really help reduce the risk of software development for our clients. Given the experience level of our team and our practice of Agile, we are able to really help our clients strike the right balance of discipline versus responsiveness for time to market kind of considerations. So striking the right balance and building quality software while still hitting the market windows is very important. We help our clients reduce and manage that risk. The fourth point is reducing the cost. We have a dual shore team, a development and testing team based in India and a product management team based in US. And with that combination of, we are able to provide a 50% cost advantage to our clients when they leverage our team. And along with the lower cost, we are able to still provide a lot of flexibility to our clients. So of course, one kind of flexibility is being able to ramp up and ramp down the team size based on the need. But more importantly, a long-term flexibility, they can convert the team that is working for them into their own captive operation if they felt like it down the line. So that's Synergip in a nutshell. The next page, as it refreshes on your screen, it has a number of logos of some of our clients. So as you see, almost all our clients are small to mid-sized technology companies, a few larger clients, but our sweet spot is small to mid-sized companies, typically later stage venture-backed companies. So that's about Synergip. Let me now come to taking some questions, and we have a number of questions here. So Chris, if you're ready, I'll take a few questions at least, and I think then we'll wrap up in a few minutes.
Absolutely.
Okay. So the first question let's take is you showed the stages, multi-stage continuous integration, and you took an example of a team size of 200 developers or so. Is there any guidance you can provide to organizations who have teams of roughly that magnitude or a little less or a little more, of how to really stage, how many stages are appropriate, and what's the right balance to strike in number of stages so that you're getting the most bang for the buck in terms of response, in terms of quality of software without the noise that you talked about?
Yeah, great question. You know, I think that there's a lot of factors to consider here, and one of them is how is your code structured and what are the dependencies in your code base. So, you know, if I have a team of 100 people and there's 10 people on each team, is it possible for me to create 10 different stages of the continuous integration build? Yes, but that depends on what your code base looks like and how the code depends on each other and how the interplay between the teams depend on each other. So what the dependencies are between teams in terms of what binaries they need to share, what code they need to share. That said, I believe that, you know, the rule of thumb is to try to break it up as much as possible and break it up by useful feedback for those teams. All right, so that means that if I could have 10 different builds running at the same time for those teams and provide feedback to them, absolutely I would want to have 10 different builds. Are there some that have to be grouped together, of course, for whatever needs there are? Yes. Is it possible to do it based on the build system that you have and you build scripts and the way the code is structured? Well, that's going to be up to you to try to figure that out. But really, the rule of thumb here to get the best bang for your buck is try to parallelize this and break this up as much as possible and not rely on one huge big bang CI build that's not providing the same type of feedback or the kind of feedback that we actually want. That's really more of a waterfall type thing.
So is there any guidance, just to follow up on that question itself, which is number of stages, how many stages are too many for a certain size, or there's no such thing, it all depends on the code?
Well, I mean, you can certainly have too many stages where it would just get to be cumbersome to try to move everything between every different stage. You want to have as many stages as you do to match your development process. For example, maybe I take a whiteboard session one day where I work out the development process with my team and I figure out all the different environments maybe I deploy to, or all the different states of code that I actually go through on my way to production. And, you know, just thinking about how that matches up with the builds and how that matches up with the different code configurations you might need along the way is really how you're going to figure that out. Yes, you can end up in a situation where you have too many stages, but you can avoid that by simply creating them based on whatever needs you have based on your organizational needs, I would say, if that makes any sense. So you really want to, yes, you can have too many stages, but just break it up by what your development process looks like. Mirror your development process right into this, right into the build structure and the SCM structure.
Okay. Let's take a related question to this topic then. So to be able to lay it out appropriately for a development organization based on all the right considerations, is this something the development team does it in-house, meaning the development manager or someone in the team will be able to help lay out the right continuous integration setup, or is this an external expertise that needs to be brought in for the purposes of doing it the right way?
I believe this is something development teams can do themselves. Obviously having the right tools at your disposal is going to help you, and you can always go outside for some external expertise, but you're going to know this process better than anybody else, and every development team is different, so it's up to them to kind of try to manage that process and try to map that process to this multi-stage continuous integration setup. Typically the players involved in this type of setup are usually a release engineer or a software architect. These are the type of people that would have intimate knowledge of this process from a high level to try to set up the builds in that staged manner.
Excellent. All right, let's take a different question now on investment required. So you have you showed about the value in a page of $1.2 million or so in a team of 200 developers. So in that kind of a situation, what's the level of investment that a team needs to be planning for in terms of people, tools, other infrastructure that is required to actually have the right kind of setup for continuous integration?
Right. So this is a very tricky topic, and of course, like I keep saying, having the right tools, to help you do this. If you get Hudson or Inhouse Pro or Accurev or Subversion, whatever tools you want to do to kind of set this up, that of course is going to maybe cost some money. But in terms of infrastructure, it's largely dependent on how many builds are going to be running and the nature of those builds. All right, so if I run a build that takes 3 minutes, I'm probably not going to need that many machines or that many places or resources to put this build. If I have a very large build that takes several hours, I'm probably going to need a larger build farm to do that. So in terms of infrastructure and setting that up, that's where the major cost is going to come from. It's dependent on how big the build is. In terms of the infrastructure required to just set up that entire process, it's not very expensive to set up a multi-stage continuous integration process. It's really the resources and where the builds are going to be coming from and how large those builds are. In terms of in terms of what people are involved, there is a cost to just really getting everybody together in the same room and really talking about these things and kind of setting up that process. And that cost usually comes from your release engineer, your architect, as like I said before. But typically they're thinking about these things already, and this is just part of their job. So this is another tool that they can use, another process they can use to kind of improve their development process.
Right. So, I mean, this may be a bit of a stretch, but I'll ask anyways, since we have that number, 1.2 million in the page, is there a kind of a back of the envelope investment required that is for the similar situation of a 200-person development organization? If the savings or the value is 1.2 million a year of a better continuous integration process, what's the investment required to achieve that saving?
To tell you the truth, if it's a strict numbers or money investment, I'm not entirely sure what that number is, but I do not believe the investment is anywhere near $1.2 million. I believe it's in the thousands range, and it's really more about time and people than it is about tools or how much those things are going to cost or what kind of consulting fees you're going to need or those types of things. It's really about how much time you can spend investing in developing a homegrown system that does this or purchasing tools that do this kind of stuff. But it's nowhere near $1.2 million for a 200-person development team.
Right, right. And of course, we didn't at all attribute any dollar value to the quality result, which is probably even bigger than 1.2 million in this case.
Right, right. And the 1.2 million was actually very conservative, which is shocking. When I did this, sometimes when you make these presentations, you always go in and you want to put in conservative numbers to, show people the reality of the cost of these things. And I tried to make these as conservative as possible, and it still ended up being a ton of money, which was really funny. So, yeah, I just thought I'd point that out.
That makes sense. Okay. A little more tactical question for people who are thinking along those lines but are not there. Clearly, any advice you can provide on what is out there for them in terms of tools? And I'm sure there's a gradation of tools. If we can provide some advice along the continuum of a small team, what kind of a no-brainer tools they should be using for configuration management and continuous integration for that environment, small, perhaps 20-person team. If it is a 100, 200-person team, what's the next level up? And then if it is an even larger distributed team, so that's
sure
kind of a guidance you can provide along the way.
Sure. If you're a small development shop and you have 10 people on your team, absolutely Subversion and Hudson are great tools, no-brainers. Just use those. And they're both excellent at what they do, which is simple continuous integration and simple source code configuration management. Anything, when you start to get a little bit larger, like 20 people, things get a little more complicated. Like with that diagram we had before with the people writing a book, all the dependencies kind of in the way that people interact with each other kind of get really jumbled up in the way that the software development process works. And your tools have to improve to go with that or scale to go with that. So for that, I'd obviously say Accurev is the perfect choice for someone that is in one of those larger teams, especially if they're distributed. Anywhere between thousands of people or 20 people would be a great fit. And then some of the other tools that do continuous integration deploy are, I believe, uBuild and uDeploy from Agile Pro is a great choice. And then there's also Electric Cloud's offerings for CI, and that's really going to handle the build portion of it, that automation portion. So if we remember that slide that had the different code stages and all the different things that happen at each code stage, all the automation, Urban Code and Continuous and Electric Cloud are really going to provide that automation for you, and then Accurev can be the process layer underneath it.
Okay, excellent. That's good advice. Thank you so much. I think that's pretty much all the questions that make sense for us to take. There's some specific questions, but I think we can postpone them for a separate discussion. But thank you so much, Chris, for taking the time, and thank you all for attending. I think we're good in wrapping up a few minutes before our scheduled end, so this is good. So you guys have 5 minutes additional for the day today. And we'll have another webinar in a month. Thank you, Chris.
Thank you, everyone. Bye now.